Alright, this is the second phase, measure phase. Let us continue and discuss further on the measure phase. So we have discussed these three things in define phase. How to generate project ideas, how to select the project, and finalizing the project charter and high level map. In measure phase, we are going to discuss on how to finalize the project Y, performance standards for Y, how to validate a measurement system for Y. We'll spend some time here. And measure current performance and gap. We are going to discuss few more things in addition to what we have discussed in green belt. So for measure phase, we need project charter as an input. We need critical customer requirements and high level map as input. Once we have these three things as inputs, we are going to ensure that the measurement system is providing good and reliable data. We collect data and establish a baseline for the project against which future improvements can be compared. So we're going to baseline the current performance. As of today, how is my process performing? At what sigma level or what is my capability level with the data that I have as of today? And the end result would be valid measurement system. I would have validated the measurement system, and only if I find it valid, I'm going to proceed with the measurement. Then I'm going to baseline the performance. As of today, what is my process performing at? What level is my process at? Then I'm going to baseline the sample statistics. Then I'm going to come up with a detailed process map and then list of potential inputs that are impacting my output. These list of potential inputs would be overlapping with your analyze phase. In that also, you try to list down the potential inputs. Performance standard metric. For the primary metric, that is project Y, we are interested in Y. Y is equal to f of x. In the define phase, we have identified Y. For the primary metric project Y, we define how we measure the characteristic. What is the definition of the defect and where the data is obtained from. Right, this is a simple table in which it explains about various things. For instance, data type is continuous or discrete. All right, here are few other examples. What is a metric? This is how you write a metric. Length in feet from the left door to right door handle. It should be very clear, whatever you mentioned. For discrete, number of errors per invoice for each invoice. And what is your target? My target is 3.2 feet. The length in feet from the left door to right door handle in a car, right? It should be 3.2 feet. Number of errors per invoice should be 0. Specification plus or minus 0.1 feet. What does this mean? Plus or minus 0.1 feet. If the target is 4.2 feet, then my USL will be how much? 4.2 plus 0.1, which is nothing but 4.3 feet. And what will be my LSL? LSL will be 4.2 feet minus 0.1 feet, which is equal to 4.1 feet. That is what this means. Here it is less than 1 error. So my USL is clear. It should be less than 1. How do you measure? By doing a laser check. This I'm measuring what? Door, car door. Right? And when it comes to invoice, it is a visual inspection. And by the way, nowadays this visual inspection is getting rid of. Instead of visually inspecting, what people are doing, people are just attaching a high-end camera on the top. They are fixing a high-end camera on the top, and you should just pass your applications through that camera. That's it. That camera is going to capture everything, quickly analyze, and tell you if there are any defects. So the manual process of checking anything is going to come to an end in the near future. Then comes the measurement frequency. How do you measure? I measure one car door per week. Here I'm going to check once in a month. So this is just performance standard matrix, which is going to tell how am I going to measure. Here we have given example of continuous data, and here we have given example of discrete data. In continuous data, if I have a car, what is the metric that I'm using? Length in feet from the left door to the right door handle. So how many opportunities for defects are there? There is only one opportunity for defect per unit, means per car door. What is the type of data? If you're measuring length in feet, if you're measuring length, I can say 5.5 feet or 5.1.6 feet. It varies. Hence, it is continuous data. This is the target as specified by my R&D team. And these are the specifications. Specifications are required to calculate your USL and LSL. Then I'm also telling what is the measurement source. How will I measure? Using a laser. And how often do I measure? Once in a week. And there is another example given here with respect to discrete data. I'm checking the invoices. I'm checking how many errors are there in each invoice. Each invoice has 15 fields: name, date of birth, address, so on and so forth. I have 15 things. So there are 15 opportunities for error. It is a discrete data type because you cannot say there is 1.2.3 defects or 5.6.8 defects. All you can make a statement is about whether there is one defect or two defects or three defects or 4, 5. It will be a whole number. You cannot divide it further. Target is I want 0 defects. Specification is USL is less than 1 error. I don't want any error absolutely. How am I measuring? I visually check each and every invoice. How often do I do it? Once a month. So this is a simple performance standard matrix. Then data collection. I need to collect the data. Now the first thing that you have to do is look for data that is already collected. If it is not already collected, then you will need to collect the data. But first things first, do not waste time. If you already have the data, use it. If you do not have the data, only then you need to collect the data. If the cost and time permit, you can work with the entire population data. If you have the time and energy and cost with you. If not, work with the sample. If a bank wants to check whether the new credit card promotion is going to work or not, they cannot give that new credit card to all the people, all their banking customers, right? It will be an overkill. It's related to a lot of costs. You need to generate a lot of cards, credit cards, give it to them, give the new promotions, right? Who is going to maintain the register of all these people to whom you have given the credit card? It's a difficult proposition. Hence, you always, most often than not, work with a sample only. Population getting access to it is very difficult. For example, I want to check how many iPhone users are happy with the features. Then can I go and ask each and every iPhone user on whether they are happy with the iPhone new features? It would be difficult. Where will I go and access? How can I collect? Just think about India alone. There could be crores of people who might be using iPhone 6. I cannot go to each and every person and ask them, do you like the features in this, right? It will be very costly for me and very time consuming. It might take more than 2 years also. By that time, iPhone 7, 8 also will come. So always I work with a sample. I randomly select maybe 1% or maybe 2% of these iPhone users. I randomly close my speaker and then I'll probably call them or SMS them or send them an email to collect the data. Ensure that the sample is representative. That means ensure that it is randomly selected. If you have population of all the iPhone 6 users, close your eyes, randomly pick a sample, maybe 1% of this entire population. Then it's called as being representative of the population. Because it's coming from the population, it's representing the population. This sample represents this population. You need to have sufficient data to cover any trends and seasonality. So how did I arrive at 1% or 2% or 20%? Right? This thing we are going to discuss. Using Minitab itself, you can calculate what can be the sample size. Okay, we will do that. And ensure that it is not biased. Not biased meaning, if I ask you to collect information about iPhone 6 users, and I want to know how many of them are happy with the new phone. I'm asking you to do this for the entire country. But since you're located in Ahmedabad, Anush, if at all you go and ask all the people in only Ahmedabad on whether they are happy with the new iPhone 6 or not, then you're being biased, because I asked you to do survey across India, and what did you do? You have picked up everyone from Ahmedabad because that is very convenient for you. Right? That is called as being biased. We should not be biased in that. All right. Next comes the measurement system analysis. Your measurement value, whatever value you are measuring, it is dependent on the true value. If I'm measuring my height, example, I'm just measuring my height. My height might be 5.8, right? But there might be slight error while I'm measuring. Maybe very small difference. That is called as measurement error. Most often than not, you'll have this. Probably my true value is 5.8, but actually my measured value comes up to be 5.7.5. Right? So what is the error? Error is my bad. Let me change this. My measured value say it is 5.8, but my actual height is 5.7.5. So what is the error? 0.05. So this kind of small measurement error will always be there, whatever you try to measure. Yes, so you cannot be 100% accurate anytime. So this measurement system analysis actually considers this, actually says that never you can be 100% accurate. It's difficult. So always there would be slight measurement error whenever you take measurements. All right. So MSA, measurement system analysis, implies assessing the existing measurement system for whatever metric you have chosen for project Y. What metrics can we choose for project Y? There are many metrics. For example, if you are measuring If customers are complaining that there is a lot of wait time in this particular bank, we had to wait in queue for long, then project Y will be wait time. Metric will be wait time. So MSA assesses the measurement system for this metric. How are you measuring this wait time? That measurement system is assessed using MSA, measurement system analysis. Then Anuj, this is one more exercise for you. I would request you to just do some research on Google elsewhere, and let me know what are the two examples, at least give me two examples of measurement errors which are observed in routine in your day-to-day life. In your day-to-day life, I can give you a classic example of my watch that I am wearing or my wall clock that is available. Always there will be a slight error. Anyone, if I asked you what is the time, I might say it is 7:37. You might look into your watch and tell me some other measurement. Right, so just in your day-to-day life routine, what are the types of measurement errors that you have noticed? You will have to just let me know, but you will have to do a research for this, Google search, etc. All right. Yeah, this is what we have just discussed, measurement system. You will have the observed value, that is the value that you are observing and making a note of. But this value is dependent on true variation and the measurement system error. So there will be some variation. Whatever value you see, if I'm asking you to take 10 different measurements, or if I'm asking you to measure my height 10 times, all 10 times you cannot be correct. There will be some measurement error and there will be some variation. That is the true variation. True variation can exist, but measurement system error should not exist. Right? Look at this. Observed variation is the sum of part variation and measurement system variation. We'll understand these in detail once we look into the exercise. But mean of, okay, we'll understand this later. All right. When data is collected, the observed process variation includes these two things. What is the actual process variation? And then measurement system variation. Actual process variation, you can't do much with that. But measurement system variation can be because of variation due to the gauge or the equipment that you're using, or it can be due to operator. Now, variation due to gauge, how do you measure? Accuracy, bias, precision, stability, linearity, all these are examples. Now, Anuj, question to you. Variation due to operator, we have already discussed in green belt. What is that?
Trying to remember. Can you give me a hint? Hello? Hello?
Yeah, Anuj?
Yeah, no, I'm just trying to remember. Can you give me any hint?
We have discussed about 4 parameters there also. And this is in the measure phase. In the project also you have done that. How did we measure the measurement system, MSA, in Greenbelt?
I think stat quality statistics or something
We
like
have
that.
measured the measurement system in Greenbelt using attribute agreement analysis.
Oh, yes, actually, yes.
What are the 4 things? Repeatability, reproducibility, team accuracy, and individual accuracy, right? Yeah, very, very, very important. You have to somehow try to memorize it. Just do one thing, Anuj.
Okay.
Whenever you are traveling or whenever you're busy, just make a note on a simple paper.
Hmm.
What are the various things? In define,
Okay.
what do we do? In measure phase, what did we do? At least the names. Attribute agreement analysis, those
Hmm.
four things. Then sigma level
Hmm.
for continuous and discrete data. Then
Hmm.
yield, first time yield, traditional yield, and rolled throughput yield. And then you have CP, CPK. CP should be
Hmm.
greater than 1.66. CPK
So
should be
what?
greater than 1.3. So these things, if you make a note of, it will be very, very easy
Hmm.
for you. Yeah.
Actually, I did, and whenever I do have time, I try to read it.
Okay.
So what I'm doing is normally I listen the lecture and making the notes,
Uh-huh. Okay.
but yeah, I didn't remember. Sorry. Yeah.
Yeah, yeah. So you can just make a note high level, at a very high level. What are the five,
Hmm.
6 points? That's it. Instead of going into the
Hmm.
depth always, you can do that. Be very helpful. All right.
Okay.
So what are the types of measurement errors? Here we have discussed that there are 4 types. So let us discuss these 4. Accuracy. Accuracy is difference between the average of observed values and the standard. We will discuss all these things using Minitab exercise. Hope you have downloaded Minitab 17, Anuj.
Actually, I did, but somehow I think I can't able to open it. And when we try to do it, I think you said we'll check it later on.
Okay, okay. So you have at least downloaded and installed or no?
Yeah, yeah, I did. I did.
Okay. So we'll be
It's in
discussing
my
about,
desktop. Yeah.
yeah, yeah, no problem. So we'll be discussing about precision also. Precision is variation observed between repeated observations of the same unit. Right? If the same person is taking repeated observations, then what is the variation which is observed? Then we have linearity. Linearity is consistency of the measurement system across its entire range. How consistent is the measurement system? If I take measurements for 1 year, it should be consistent for the entire 1 year. And then we have stability. Variation which occurs with time is stability. It is observed if the same operator measures the same unit with the same measuring equipment over an extended period. Say maybe for 3 months, 4 months, 1 year, etc. Then we look into the stability. Precision versus accuracy, this I think we have already discussed. What do you mean by being precise? Suppose this is the dartboard, this is the bullseye. If I'm continuously hitting here, I'm away from my target, but still all the data points are cluttered together, and this is called as precision. What do you mean by accuracy? If all these data points are on this dart, bullseye, then it is called as being accurate. And we have CP, CPK which describes this. If you are speaking about CP, it speaks about variation. How close are my measurements? So this is something related to CP. CPK speaks about how close is my mean to the target. And then I speak about this. We'll discuss all those things in detail. Okay, let us look at this. The dotted line shows known value of measurement. This bell-shaped curve shows the mean and variation in repeated values for the same measured item. Whenever you are observing
I can
values,
see this.
sorry?
I can see the slide. I can see the slide, but I can't see your pen.
Okay. Are you able to see the stability versus linearity?
Oh, yes, now I can see your
Oh,
pen, yeah, moving,
okay.
yeah.
Okay. Okay. So there can be linear bias or non-linear bias, or sometimes there can be no bias at all. All right. Instability. But is instability, it is inaccuracy over time. That means at 4 o'clock I take measurement. See, this dotted line shows the known value of measurement from the mean. And if at 6 o'clock I take the same measurement, I'm taking different measurement. There is a lot of gap right here. Here it's slightly more. So if I take it 4 o'clock or 6 o'clock, the instability is increasing. Inaccuracy over time. Then comes inaccuracy over value itself. So if these are my specification limits, one time I take a measurement which is close to my LSL, second time it is slightly closer to my mean, third time closer to my mean, fourth time it is closer to my USL. So each time I take a measurement, it's changing. My value is changing each time I take the measurement. So that is inaccuracy over value. Alright, next comes discrimination. The smallest division on the scale of the gauge or the smallest difference in reading that can be shown on the display of a measuring instrument. Ideally, the instrument should be able to measure smaller than 1/10 of the tolerance. Suppose you want to measure height in inches, right? So your measuring device should have 1/10 of the inch also in that. So if I want to measure height in inches, suppose this is 1 inch, then my measurement equipment, the device or gauge that I'm using should be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should measure up to 1/10 of the inch. If I'm measuring height in feet, then suppose this is 1 feet, then I should be able to measure to the accuracy of 1/10. There are 10 gradations, 10 divisions within this 1 foot. So this is how you're going to come up with your measurement device. That is called as discrimination. At least, I mean, this is at least. That means you can go to the any accuracy level possible, but at least you should be able to measure to the 1/10 of the range of variation. Yeah. Then comes calibration and traceability, which is related to accuracy. Calibration is a process of adjusting the output on a measurement system. You adjust the output of the measurement system. If I'm taking height, adjust the height, the value that comes up. But that value should be agreeable with the
So
applied.
we're in slide 12 or 13? Oh yeah.
13. Oh, is it coming up very slow?
It was. Now it's 13 now.
Okay.
The voice was little cutting down as well. Anyway, it's better now.
It's better now, right? Okay. All right.
It was very slow.
Okay. Fine. So what is calibration? Calibration is nothing but whenever you take some measurements, right? Your measurement system should always be adjusted to agree with the applied standard within a specified accuracy. So have you ever driven bullet, Anush, Enfield?
Oh. Did you?
Oh yeah, I had it during my BTech days when I was very young. Yeah, so there you have, I mean, I used to drive which vehicle which was 1982 make. So in that, there was one small thing called as air compression. Each time I try to kick to start the vehicle, that air pressure would accumulate, and then I had to release that air pressure by pressing a button. And if I do not do so, the moment I try to kick that to start the vehicle, it's going to give me a reverse kick. I mean, all the air pressure would come up with all the energy, and then that would damage our leg, etc. It would hurt
That's
real
what I
bad.
heard about it, but I never tried it.
Yeah. So yeah, I used to take revenge on my friends. I used to ask them to just try to start it. They didn't knew that air pressure had to be removed, and the reverse, the pressure with which it would come back was tremendous. Sometimes they had to go to the doctor also to check whether that's a fracture or something. So that is a power. So each time when I try to kick, and if the vehicle does not start, I have to release that pressure. So what am I doing? I'm calibrating again. So that is the same even with your thermometer. We need to calibrate a thermometer periodically, right? If you take the measurement of your kids, suppose you sense that they might be having some fever, what do? You take the readings. After you take the readings, you reset it again, right? So that is calibrate. We need to calibrate a thermometer periodically so that we can verify that it shows accurate temperature. Second thing is traceability. Traceability is the unbroken chain of comparisons to the national or international standards. So whenever I'm measuring, I check whether the gauge or the instrument that I'm using is in line with the international standards or not. For instance, we have NIST, National Institute of Standards and Technology. Then we have PTB. PTB is a German company. That name is a German name actually. And then we have BIS, Bureau of International Standards. So I need to check whether I'm continuously in line with the national or international standards when I'm taking the measurements. When I'm manufacturing a scale, check with gauges in the shop. You validate your instruments with a master gauge. In any company, in a big manufacturing company, you will have this master gauge. And no one touches this master gauge. It's kept in a secured location. Only when you want to validate, maybe it happens once a while, not daily, maybe once in a quarter or so, you want to check whether your gauge or the instrument that you're using to take measurements is still showing the correct readings or not. That is when you validate your gauges with the master gauge, with some external company also. Sometimes the master gauges are with external companies. Right, and sometimes the company's master gauges might be validated with established standard, whatever standard you have in your company. You might be aligned with the national standards or international standards. You validate your master gauge also periodically, because sometimes things change. Your NIST might come up with a better way of taking measurements. Right, your Bureau of Indian Standards, BIS, can come up with a better way of taking measurements. So every now and then keep validating your company's master gauge. The third thing is need to adequately control integrity of standards and measurement devices. How do you do that? No one is allowed to touch the master gauge for length. No, absolutely no. Master gauge is master gauge. You cannot touch it periodically and all that. You just use it as a reference. That is kind of Bible for you. Ensure that there is no rust, there is no wear and tear for the mechanical gauges. In this way, you ensure that there is some amount of integrity. Next thing is we have to discuss about precision elements. Let me know once you see the screen, Anuj. Anuj,
Which one? This
yeah.
repeatability and reproductivity?
Yeah,
Yes,
exactly. All right.
yeah, I can see it here.
Yeah. Since there is a small time lag, I thought I'll just end. All right, repeatability. What is repeatability? We have discussed in attribute agreement analysis. If the same operator is taking multiple readings using the same equipment, then all the times he has to take the same measurements. Suppose I'm asking an operator to measure my height. In the morning he comes, measures using the same measuring equipment, tape. He says my height is 5.8. After 5 days, I ask him to come back and take my measurement again. When he takes the measurement, it should again be 5.8. If it is 5.9, then he is not repeating himself. If it is 5.7, then also he is not repeating himself. Right? So repeatability means the variation observed if the same operator is asked to measure the same unit. The same operator is measuring my height, same unit, repeatedly with the same measuring equipment. That is repeatability. Reproducibility. Suppose I ask person A, must come and take my measurement. Height. He says it's 5.8. Again I'll ask.
Just give me 1 minute.
Yeah. Sure. Yeah, all right. So what is reproducibility? If I'm asking two or more operators to measure the same unit with the same measuring equipment, that is reproducibility. Let us discuss further. If I'm asking person A to come and take my height reading, he says you are 5.8. As person B, he says it is 5.8. I call both of them after 5 days and ask them to take the readings. Person A takes my readings, it is 5.8. If person B also takes 5.8, it is called as reproducibility. They are reproducing themselves. If instead of 5.8, this person says 5.7, then there is no reproducibility. They are not reproducing the same results. Yeah, so this is the difference. Then, all right, this is for you, Anuj. Once again, your example exercise. You'll have to provide me the result by doing some research. Okay, give examples of gauges in real life situations which have poor accuracy, poor resolution, poor precision, stability, and linearity. Just do some research. You'll get to know about all these things. And try to send it to me by tomorrow. All right. Then here is a
today. Yeah. No?
Yeah. We can do that, Anuj. Let me stop